Okay, so to be an exponential function, we talked about the variable has to be in the exponent. So this is an exponential function, exponential function, exponential function, but this one's not. The variable's not in the exponent for number 5. So that was supposed to be in neither. A parabola grows pretty quickly, but it doesn't grow exponentially. And the other one that was neither was number 8. Again, because the variable is not in the exponent, it is not exponential growth or exponential decay. It's just not exponential. Okay, and then these, we graphed a couple of these on the notes last time. We graphed 2 to the x and 3 to the x. And we did both of those to help you see that those basically look the same, very, very close at least. And those are examples of exponential growth. So the key here is that this number, the base of the exponent, is a number bigger than 1. So from that, hopefully you said number 3 is exponential growth. 7 to the x would look like 2 to the x and 3 to the x, exponential growth. And also number 6, this is exponential growth. Timesing it by 2 just makes it go up a little bit quicker, but this is still exponential growth. Okay, and then we only graphed one of these on the front of your notes. It was like 1/2 to the x. And I said that 1/3 to the x would look the same and 1/5 to the x would look the same. So if you think about the base here, it's less than 1. So I think you would be tempted to say this one is exponential decay. Okay, and I skipped over this one, but what do you think 7 should be? It's just like this one. That multiplying by 1/3, multiplying by 2, that makes it faster or slower, but it's still growing exponentially, or growing, decaying exponentially. The tricky ones, so even if you got all those right, number 2 and number 4. If you oversimplify these rules to yourself and you just say, oh, well, if the number underneath this is less than 1, it's exponential decay. The base is greater than 1, it's exponential growth. That doesn't work on these because of exponent rules. So you should rewrite this as a positive exponent and rewrite this as a positive exponent. And the way you can change this from a negative exponent to a positive exponent is by taking the reciprocal of what's inside. Negative exponent can become positive exponent if the base becomes the reciprocal. Now that the exponent's a positive x, now you can apply those rules. This number is bigger than 1, so exponential growth. This number is less than 1, so exponential decay. So we've seen negative exponents before, so you should catch that, but I do know, many years ago, before we did a little more practice, that would be one of the more commonly missed things on the quiz. So I would suggest that you highlight at least question 2 and question 4 there to make sure you see how I change those so that doesn't trip you up. All right, any questions for 1 through 8? Again, that's without a calculator. This quiz, which is next class, will be without a calculator. You can't just graph it and see what it looks like. Okay, the other topic that's got extra practice on here is the one topic that we skipped, a question on the front and the back of the handout last time. These take a little bit of practice, and so I'm going to go through all 4 of these with you, and then we'll use the 2 from the worksheet last time that we skipped as some guided practice to let you try and see if you get it. But out to the side, there's really, I've figured out over the years, the easiest way for students to get this is to have 3 things quickly ready to apply. So one of those says if you have a number and its exponent goes to 0, you need to know that that would go to 1. If you have an exponent that's going to 0, that whole thing goes to 1, because anything to the 0 power is 1. If you have a number and its exponent just keeps getting bigger, then this whole thing just keeps getting bigger. So if your exponent is unbounded, it's going to infinity, then some number to that exponent would also go to infinity. Okay, and then the last one, if your number goes to, or your exponent goes to negative infinity, well, first off, let's think of this as exponent rules. A negative exponent in the numerator is the same thing as a positive exponent in the denominator. A number whose exponent just keeps getting bigger will just keep getting bigger. And in a fraction, this is a really important concept here, especially in calculus. If you've got a fraction and your denominator just keeps getting bigger, so like 1/2 to 1/3 to 1/4 to 1/5, and that number just keeps getting bigger, that's going to get closer and closer to 0. So when we see we have a number and its exponent is going to negative infinity, that whole thing ends up going to 0 because of those steps. So I would suggest that you sketch those down, but that's really the key. Each one of these questions uses at least one of these. All right, so first off, I'm going to write it down here to make it a little bit bigger. What this question is asking about is horizontal asymptotes. So what is the far left of the graph doing, and what is the far right of the graph doing? Far left is as x values get extremely small as they approach negative infinity, and the right side of the graph is when the x values get extremely big, approach positive infinity. Okay. So let's do the left side first. As x approaches negative infinity, what you should do is plug that in for x. So x is going to negative infinity. X can actually be negative infinity, but for simplicity, we kind of plug it in. And then we have to figure out what's going on in this big mess. So if you look at this, well, if you know these things up here, this is the third one down here. I've got a base, that's a number, e is just a number, and its exponent is going to negative infinity. So because this equals this equals this equals this, all of that goes to 0, which means the denominator goes to 2, which means the whole fraction goes to 7/2. So I don't know much about what that graph looks like, but I know if you look on the far left of the graph, the y values are getting closer and closer and closer to 3.5. The further you go to the left, the closer the y values are getting to 3.5. Okay, now you should keep this on your paper. I'm going to erase it just for space here. But the right side of the graph is when you plug in positive infinity for x. Okay, so now I guess the complicated thing is I've got a number like e and its exponent's going to infinity. Well, again, if you know these three things, if you're actively looking for these, then it's a lot easier substitution. A number that goes to infinity, the whole thing goes to infinity. If you add 2 to a number that's going to infinity, it just goes to infinity, a little bit quicker, but it's still going to infinity. And then in our fraction, if the numerator is stuck at 7, but my denominator just keeps getting bigger, then this fraction is kind of like this last step here. This whole fraction would go to 0. Okay, so I'm not going to graph all of these, but I would like you to see it doesn't want to work there anyway. Okay, but if we graphed it, I know the far left of the graph, this is what the values are going to, and the far right goes to that. That's what it means by horizontal asymptotes. The extreme left, the extreme right. Okay, so let's look at another possibility, because sometimes these numbers can be different, and then sometimes they can be the same. so there's our function for 10. So the far left of the graph is when x would be approaching negative infinity. So substitute that in there. Okay, and then you have to figure out what's going on in this big mess. So for this one, we really probably should do this step first. 2 divided by a number that goes to infinity, this fraction would go to 0. I guess one's positive and one's negative, so technically this would be 0. But negative 0 and positive 0 are the same thing, so that doesn't really matter. This matches up with number 1 here. If I've got a number and its exponents going to 0, then that whole thing goes to 1, which means the denominator is going to 2, and the whole fraction is going to negative 5/2. Okay, and if I erase that, and instead check out the right side of the graph, so positive infinity, and see what that does differently. So now I've got e to the 2 over a number that goes to infinity, so let's just worry about this exponent first. 2 divided by a number that goes to infinity would be 0. Okay, this, if you've got a number and its exponent's going to 0, that goes to 1, which means the denominator goes to 2, which means my whole fraction goes to negative 5/2. So that particular graph, the left side of the graph and the right side of the graph are both approaching the same y value. They don't have to, like number 9, but they can, like number 10. Okay, so let's keep going. Number 11. Okay, I'm going to walk you through all the steps of this one, and then the next one I'll have you think about each step before I tell you. So to figure out the left side of the graph, we're going to plug in negative infinity for x. And hopefully you've seen from the first 2 examples here, you can't just look at all this and say, oh yeah, that's going to 5, or that's going to 3/8. Like, that's too much. You have to think like, I really need to figure out what's going on here, and before I can do that, I need to figure out what's going on here. So the rest of this is just kind of along for the ride for a moment. A negative times a negative would be positive. 5 times a number that goes to infinity would be a number that goes to infinity still. Now, this matches up with number 2 above. Got a number and its exponent is unbounded, just keeps getting bigger, so this whole thing will be unbounded. This whole thing will go to infinity. And if you have a number going to infinity and you subtract 3 from it, I mean, it's a touch slower, but it's still going to go to infinity. And in a fraction, if your numerator is stuck, but your denominator just keeps getting bigger, that whole thing will go to 0. It's going to just keep getting smaller and smaller. So again, I have no idea what that graph looks like, but from plugging that in and tracing those steps, I understand now that the far left of the graph, the y values are going to get closer and closer and closer to 0. The smaller the x value, the closer it is to 0. Okay, and then second half of the question is just what happens if I plugged in a positive infinity instead of a negative infinity. Sometimes there's a difference, sometimes there's not. Okay, so again, up in the smallest piece, or the most inside of all of this function is where I want to start. A negative times a positive is negative. 5 times a number that goes to infinity would go to infinity. This matches up number 3 here. I've got a base that's a number, and its exponent goes to negative infinity, so that whole thing is going to go to 0. And again, that's why I think it's helpful to have these, quickly have those as a reference. I'd even suggest writing them down on the quiz so you have a visual. Because it makes it takes so much of the thinking out of it. You just have a reference up there. Which means the denominator goes to -3, which means the fraction goes to -2. So the far right of that graph, the y values approach -2. Okay, so hopefully you can kind of see my approach here. So again, I will walk you through number 12, but I want you to try to think about each step before I say what it is, so you can kind of see where you might be off. Okay, let's do the top one first. As x approaches -infinity. So go ahead and write down what you think the first step or two should be, and then I will tell you what the first step is. Okay, the first step was just plugging in -infinity for x. All right, think what you should do next. So the next thing you should have attempted to do was deal with this exponent on e. Try to figure out what all of this mess comes out to be. So I think it's good to think about the signs. A negative divided by a negative is positive, because sometimes that matters. And then 4 divided by a number that keeps getting bigger would go to 0. That's this, the end of this. Okay. So make yourself a note there if that's where you have a mistake, and then try the next step. Okay, so the first step was to plug in -infinity, which I think that's easy enough to remember. I think looking at this and seeing that this comes out to +0 is probably the toughest step. But if you get to this step and you write these 3 things down, then I think you'll be fine, because now this is step 1, or clue 1. A number that's exponent is going to 0. The whole thing goes to 1, which means your whole denominator was going to 4, which meant your whole fraction is going to 1. The far left of that graph approaches 1. Okay, for the second half of this question, we're just plugging in a positive infinity instead. So that might change this, might change that, and it could change your answer. So now that this is positive infinity, rethink about what that exponent comes out to be. Okay, so the only difference is 4 divided by infinity is still going to go to 0, but now it's a negative divided by a positive, which is technically negative. Again, you need to make that part of your thought process because occasionally it can mess up your question. In this case, it doesn't because negative 0 is the only number that's the same thing as positive 0. So we ended up with 3 plus 1. A number that's exponent goes to 0 was 1, which means its denominator went to 4, which means the whole fraction went to 1. So my calculator on here is not working, but normally I like to graph these for you guys so you can see what we're trying to do here. But far left and far right of the graph, what y values it's approaching. Okay, so now our handout from last week, we had skipped these question types just because last time had enough information. But on the front page, so not the notes, the worksheet 1 and 2. Question A here, we had skipped this, but that's what we had just practiced. So I want you to try both parts of that and see if you can figure out what y approaches. So you do need to have this as part of your answer. Don't just have a number. Y is going to what, y is going to what. And then I will go over it and help you check it. We'll flip it over and practice that one on the back side. But then we can move on. Okay, so again, there's not too much space here for me to write, so I'll have to erase, but you should have plugged this in. So 6 over 2 plus e to the negative 0.8 times negative infinity. You should have tried to figure out what was going on in this exponent first. So a negative times a negative would be positive. 0.8 times a number that just keeps getting bigger would be a number that just keeps getting bigger. Okay, and then you should look at this and say, well, if you have a number that goes to infinity, that's one of the 3 things I told you will come up in each question. So should be looking for this. This would go to infinity. If you add 2 to a number that goes to infinity, it still goes to infinity, just a little bit quicker. And then 6 divided by a number that goes to infinity would be 0. So the far left of that graph, the y values approach 0. Okay, the far left of the graph, or I'm sorry, far right, would be plugging in positive infinity in for x. So as we saw, sometimes that makes a difference, sometimes it doesn't. You shouldn't just you shouldn't guess. You need to plug it in. Think about 0.8 times infinity is still infinity, but now it's negative times a positive, which is negative. And if we have a number whose exponent goes to negative infinity, that whole thing gets close to 0, which means your whole denominator gets close to 2, which means your whole fraction approaches 3. So if you're making a mistake there, that's understandable. It's kind of hard to catch on at first, but the main thing is you just need to really mark what you didn't think of or what mistake that you made so that you've got something to refer to. So go ahead and make those corrections if you need to, and then we can flip over the page. And there was one on the back from last time that I was going to have you practice. And then we'll go over and finish that because we didn't have time to check all that last time. Let's give everybody another minute. Make sure everybody has time to really think through it. Okay, so you should have plugged in negative infinity to start off and not worried about anything else yet. Then to figure out what this whole mess is doing, your first goal was to figure out what this exponent's doing. So positive divided by negative would be negative. 2 divided by a number that goes to infinity would go to 0. That always happens in a fraction if your denominator just keeps getting bigger and your numerator is stuck. But negative infinity is the same thing as positive infinity, so if you forgot the sign, you got lucky on that question. You should know that all of this goes to 1, because if you have a number whose exponent goes to 0, the whole thing approaches 1, which means your whole denominator approaches 3, which means your whole fraction approaches 3. 9 over 3 would be 3. Please don't just put 3. You need to say y approaches 3. You need the y arrow there. Okay, and then if I backtrack just a hair and then say, okay, instead, what if I had plugged in a positive infinity? Well, now, positive divided by positive is positive. 2 divided by a number that's unbounded would go to 0. And so now it works out the same as the last question, because positive 0 and negative 0 are the same. So again, this goes to 1, this goes to 3, and so the whole fraction goes to 3. But how I know some of those things so quickly, like how do I know e to the 0 goes to 1? It's because I'm thinking in my head, even if I'm not writing it down. That's one of the things that comes up. That's another. And then that's the third. Not any question is going to use all three of those, but every question is going to use at least one of those. Yeah.
Whenever the exponent is like, whenever it's always a number divided by the x, are the y's both going to be the same answer each time? Then all the other ones involved in this again.
Yeah. Yes. Okay, so I started to graph this. I didn't hit enter yet, but just as important is for you guys to understand what we're trying to say here. This graph, probably a fairly complicated graph that we don't know what it looks like, but if we care what the far left looks like and the far right looks like, which is the same thing as horizontal asymptotes, if it approaches a number, that's a horizontal asymptote. We're just trying to predict what that number is going to be. So here's this one graphed. And notice, so at -3, it's about 3.6. But as I get smaller and smaller and smaller, my y value here is getting closer to 3. Okay. So let's say by -10. Even by -10, it's already at 3.2. So this goes to negative infinity. We went way out here. Those y values are going to be extremely close to 3. So that's what it is on the left side. And then on the right side, we can see the y values approach the same thing, positive 3. If I graph the one from the other page, where the values are different, I want you to see the visual of what we're trying to find analytically. So we said on the far left, the y value should be getting close to 0. So we can see that here. Even just going out a few to the left is enough to see that it's going to 0. But on the far right, the y values are approaching 3. So different values on each side. So that's the visual of what we're trying to do. But by plugging in positive infinity and negative infinity and having those couple references, we can figure out the rest. Okay, any specific questions you guys see on that? I would recommend that you go back and try those again as well. Not that it's like a big part of the quiz, but there'll be a few on the quiz and there'll be a few on the test. And I would give you a book assignment to have you practice more of those, but the ones that the book provides is what I put on the other worksheet already, so it doesn't give a lot of practice there. Okay. Then let's go ahead and check the rest of worksheet 2, which was the back of what you did last time. We already checked A through I, is that correct? Okay, and then I had you work the rest of this. Is that correct? Okay. So, J through N, in this little section, 2 of these I told you wouldn't be quizzed on, but I want you to at least see them and hear them. That would be J and N. Sometimes these exponential functions are referred to as transcendental. Again, you don't need to memorize that. And N, that number E, Euler's number, that's about 2.718. It comes from taking 1 plus 1 over x to the x power as x goes to infinity. Again, you do not have to memorize that for the quiz. Okay, part K asks for a detailed graph of what we had done above. So the information that I would use is, I don't know, there's a couple points here. So 1, 0, 0, -1/2. We also have a horizontal asymptote at y equals -1. Asymptotes, we'll have to talk more about those this year. I don't think y'all got too much practice with asymptotes last year. But horizontally, it means the ends of your graph approach those numbers. So that's what we were doing by plugging in infinity and negative infinity. We just don't need to do that on these. Like, I guess you could, but it's got this. And my main suggestion to you last time was to sketch the parent function, do the first transformation, do the second transformation. So if I know generally the graph of the shape of the graph looks like this, then you should have been able to do it like so. You can always plug in more points like 2 and 3 and 4 into the function and solve for y, and it would be just a touch more accurate, but that would be plenty fine. Okay, so horizontal asymptotes. Again, calculating it shouldn't be too hard, but the idea behind it's important, and when we do rational functions before the year's out, almost all those functions have that. So it's when either the left side of your graph, the right side of your graph, or both approach a certain y value. So this is getting closer and closer to a y value of y equals -1. But it can't cross it. It doesn't actually equal it. That's what's going to happen with the horizontal asymptote. All right, a test that has to pass to be called one-to-one. It has to pass the vertical line test, which tells us that it's a function. And it has to pass the horizontal line test, which tells us its inverse is a function. And so vertical line test is when you draw a vertical line and then hits your graph at most once. Passes that. Horizontal line test is when you draw a horizontal line and hit your graph at most once. Now it's tempting to say maybe it would fail here, but these are technically going down. They are getting smaller. So it passes both of those, so you should have said yes, it is a one-to-one function. The other thing I wanted to say about asymptotes, though, is there are vertical asymptotes. Exponential functions just don't have vertical asymptotes. It almost looks like this is one because it's rising so quickly, but vertical asymptotes occur when you try to divide by 0. So, let's see. Like if I tried to graph 1 over x plus 3, or let's say minus 3. Plugging in 3 is division by 0. And when you try to divide by 0, your numbers get really big and really small really fast. So one of them goes to infinity, one goes to negative infinity. This is an example of vertical asymptote. But these graphs won't have vertical asymptotes. Okay, and then I had you practice the last two also to check today. Okay. All right, so the interest formulas that you do need to know is you need to know the Pert formula is the compound an investment or a loan that's compounded continuously. And your starting amount goes in P for principal. You need to know E is a number, so don't plug anything in place of it. R is the rate that has to be plugged in as a decimal. And T is time in years. So without a calculator, that's all you can do. You just show the numbers plugged in. Our quiz will be no calculator, so that will be what we ask you to do. If it's not compounded continuously, the other one you have to have memorized is sometimes called the Pert formula. So P still stands for principal. That's a 1. R is still the rate, entered in as a decimal. T is still time in years. But what's unique about this one is it's not compounded continuously, so you have to tell it how often it's compounded. So N represents the number of compounds per year. So if it's compounded daily, that would be 365 times in a year. And without a calculator, that's what we would be looking for as an answer. Now, it's not a bad idea to go ahead and practice putting it in the calculator. I think if you saw it on the ACT test, they would actually have numbers. They would expect you to plug it in. All right, and then the last of the application questions that we will ask of you on the quizzes and the test in this unit, the half-life stuff. So we've got an asymptote or isotope that has this much mass in grams represented there. And technically both answers are sitting there in the formula, but I don't, unless you just know that from chemistry or something, I'd rather you actually work it out. So initial mass would be at the start or when time is 0. So plug in 0 for time and solve. 0 divided by anything is 0. Anything to the 0 power is 1. 10 times 1 is 10. So at the start, you start off with 10 grams. And then the idea of half-life is how much time has to pass before half of it has gone away, deteriorated away. So if you started off with 10, when it reaches 5 grams would be its half-life. So set the equation equal to 5. 5 is half of 10. Oops. And solve for the time. How much time has to pass before that equals 5? So you should have divided both sides by 10, which gives you 1/2 equals 1/2 to the t over 2012. And part of what makes logarithms so important is solving equations like this, but this one's been rigged where we don't need logarithms. 1/2 to the first equals 1/2 to the t over 2012. The only way these are equal are if the exponents are equal. So in the end, you should have set 1 equal to t over 2012, which would happen at 2012. For whatever made up isotope that is, to go from 10 grams to 5 grams, it would take that many years. But again, I know the answer is in the formula there, like it's right there, but you might remember that for the quiz and then not for the test. It's better to just think about what is half-life, set it equal to that, and solve, because it always kind of solves the same way, so you can figure it out in a moment. Okay, so let's look at the stuff that you will be expected to do, give you a chance to review it, and give you a chance to speak up and ask questions, because I know some of it wasn't since last week. But worksheet 1 and worksheet 2 look the same, so you should expect some variation of all these questions. We graphed exponential functions. So knowing what a generic exponential growth looks like, what a generic exponential decay looks like, and then applying those same transformation rules we used last semester. Shifting left 1, reflecting the x-axis, shifting down 1. Once you have the graph, you should be able to answer certain things about the graph. Should know what a one-to-one function is. You should be able to apply this information to get a nicer looking sketch. That's what I did for you last time. These horizontal asymptote rules that we had 4 of on the extra practice today. The compound interest formulas, and I will highlight. You have to know those 2. You have to have those memorized. We will not provide those 2 for you. And then a half-life type question, similar to C. Okay. Anything that stands out that you want to discuss again?